What is up, everybody, and welcome to this video on blockchain consensus mechanisms and the role it plays in the security and decentralization of a blockchain network. First things first, let's talk about decentralization, this big keyword. You know how every single group project in school always has that one person who tries to take control and do everything themselves? Well, luckily, a blockchain is the opposite of that. It's decentralized, meaning that it's not controlled by any one person or groups of people. Instead, it's maintained by a network of computers or nodes that work together to validate and record transactions. It's essentially just like the group project where everyone actually does their fair share. But why is decentralization important? Well, having a larger number of nodes on the blockchain helps to ensure the security and integrity of the data on the blockchain and the entire blockchain. So you can say more nodes will equal to the more security on the blockchain. The more nodes there are, the harder it is for any single entity to take control of the entire network or to manipulate the data on the blockchain. It's just like trying to steal the group project from a classroom full of students rather than just one student. And if there are not enough nodes on the network, this will lead to the dreaded 51% attack. This is the nightmare scenario for any blockchain network. It's when one entity or group of entities control more than 51% of the network's mining power. With this much control, they could literally just potentially manipulate the data of the blockchain, and they can carry out all sorts of nefarious deeds. It's just like the group project dictators taking over their class. So essentially, that's a quick overview of decentralization and the importance of having a larger number of nodes on the blockchain networks and the dangers of a 51% attack. So because of all these dangers of having very little nodes on the blockchain, how the heck do you incentivize nodes to join your blockchain? This brings us to the main topic of today, consensus mechanisms. Now, if you don't know what consensus mechanisms are, that's good because you came to the right place, our video. And I'm pretty sure even if you haven't heard of it already, if you've been hearing about crypto blockchain for a while right now, you probably heard of these two terms, proof of work and proof of stake. And you probably heard of these terms repeat a lot. Probably recently you heard more about proof of stake because of the recent Ethereum merge that happened. We'll get into it a little bit more later. But for now, let's cover proof of work and the consensus mechanisms, because this is crucial to incentivizing more nodes to join so our blockchain doesn't fall for the dreaded 51% attack. So let's start with proof of work. So proof of work is the thing which turns your computer into a hot and noisy brick and your electricity bill into a small fortune. But hey, at least you're contributing to the security and decentralization of the blockchain, right? And let's be real. What's a little extra heat and noise compared to the satisfaction of being a part of the decentralized revolution on the blockchain? So essentially, proof of work actually it's just like a giant math competition. For example, like the math Olympiad. But instead of getting a medal or trophy from the math competition, you get a tiny fraction of digital currency or crypto that may or may not be worth anything in a few years. Sounds fun, right? Seriously, jokes aside, this kind of is the point of proof of work. Proof of work is a really important concept in the world of crypto and blockchain. It's a way of securing and verifying transactions on a blockchain network by solving complex mathematical puzzles. And no, you can't just Google the answers. So what does this exactly all mean? Essentially, miners or nodes on the network will compete to solve these math puzzles, and they will create new blocks on the blockchain. So the first one to do so, to solve the math problem, gets to add the block to the chain. And then when a block is added to the chain, they will be rewarded with a certain amount of cryptocurrency. So this certain amount of cryptocurrency is the incentive for nodes to join the network and mine together to add blocks and earn crypto. So it's essentially, again, it's just like a digital scavenger hunt, but instead of finding hidden treasure, you're just finding more math problems to solve and more crypto to earn if you could solve the math problem first. So that's why I said it's like a math Olympiad or math competition. And no wonder most of these miners on the Bitcoin network, very obviously very popular proof of work blockchain, are Chinese. Pun intended, but Yeah, no wonder there are Chinese. It's math competition. So yeah. But essentially, to sum it all up first, proof of work helps to prevent fraud and tampering on the blockchain. It will be practically impossible for a single miner or groups of miners to take control of the network and manipulate all of the data. It's like trying to solve a Rubik's Cube while blindfolded and with your hands tied behind your back. Proof of work helps to decentralize the network by requiring a lot of computing power to solve complex mathematical puzzles. It will be really expensive for any one entity to try and take control of the network, as they will need to have a majority of the mining power. Just like the group example, it's just like trying to steal the group project from an entire school. So these are the benefits that proof of work brings to a blockchain network. But as much as we love proof of work, it's not really that perfect. One of the main issues is the amount of energy it requires. The complex mathematical puzzles that needs to be solved require a lot of computational power, which in turn requires a lot of electricity. It's like, imagine you have a small city and you're trying to power it with a single outlet. So as you can see, the energy consumption on the proof of work blockchain is actually significantly higher than these other examples. And actually, this is one of the major critics of blockchain for those no corners. But we can actually consider that this argument is possibly going to be over in the future, as we have better alternatives to proof of work that I'll get into soon. And let me talk about two more disadvantages of proof of work. Proof of work can actually also lead to centralization of the network. So if you don't understand what this diagram means, let me explain. Since the math puzzles, require a lot of computational power, only those people with access to specialized high-power equipment can effectively compete as miners. This will create a barrier to entry for smaller players, and it will lead to a concentration of mining powers in the hands of a few larger players. So imagine you have like someone has one of these, like some rich billionaire has one of these big ass async machines, and these async machines are actually really powerful for mining, for example, Bitcoin on a proof of work network. And imagine you have like 100 of these computers. Obviously, the async machine will still win. It's just like trying to play football against Messi with a pair of flip-flops. So this actually will lead to centralization of the network being bossed by these big computers. Finally, proof of work can really be slow and expensive, as the puzzles take time to solve and the competition for the crypto rewards can drive up the transaction fees on the blockchain. It's just like trying to get through a busy airport on a holiday weekend with only one slow-moving securities checkpoint, and that sucks, right? But despite all these drawbacks, proof of work still remains a popular and effective consensus mechanism for many blockchain networks, for example, Bitcoin. However, it's important to consider these disadvantages and explore alternative solutions, such as what we're going to talk about now, proof of stake, that may address some of these issues. It's like trying to find a new route to work toward traffic in this airport example. So again, I'm pretty sure you guys recently heard of proof of stake, but in fact, it's been here a long time. It just took Ethereum a long time to implement it. So again, you guys heard of the Ethereum merge. Essentially, what this was that it was a transition of the Ethereum blockchain, because Ethereum was using the proof of work consensus mechanism before. Now it's using the proof of stake consensus mechanism. So in a way, it's like Ethereum's getting rid of proof of work, what we just covered, and moving towards proof of stake. If you guys want to find a more in-depth video about this entire Ethereum merge, be sure to check out Sebastian's video on our channel titled The Merge. So proof of stake is another consensus mechanism that is used by some blockchain networks. So instead of using computation to solve complex mathematical puzzles in proof of work, proof of stakes requires users to stake or commit a certain amount of crypto as collateral to order to validate transactions and create new blocks. So the more crypto the user stakes, the higher the chances of them being selected to create a block and earn the reward. So now it's about how much crypto you have rather than the computation you have. But one of the main advantages of proof of stake over proof of work is that generally it's more energy efficient than proof of work, as it does not require that much computational power. So as you can see, even proof of stake is significantly using much less energy than these other things like Bitcoin proof of work, YouTube, gold mining, uh, gaming, PayPal. It's using significantly much energy for proof of stake, and this obviously makes it more environmentally friendly and cost effective. Proof of stake also has the potential to be more decentralized and it does not require specialized hardware, and it could be accessible to a wider range of users. However, there are still concerns about centralization and the potential of users with large stakes or billionaires to have disproportionate influence on the network. So thank you for watching our video. In this video, you guys learned about centralization, what's the need for it, consensus mechanisms, and proof of work and proof of stake, which is one of the backbone of how a blockchain works and functions. Thank you for watching the video.